9702 May June 2015 paper 2 variant 1 and the topic is from the momentum. Question number 3. Two balls X and Y are supported by a long string as shown. The balls are each pulled back and pushed towards each other when the ball collide at the position shown. The strings are vertical. The balls rebound in opposite direction. So the information is given as the ball x, the mass of the ball x, mass of the ball y m, velocity just before the collision is positive 4.5, and after collision minus 1.8, and for y minus 2.8, and after collision plus 1.4. The positive direction is horizontal and to the right. So this is given. So use this information and use the conservation of linear momentum to determine the mass m of y. So before collision is 50 momentum before collision of we need to add, right? So before collision is 50 and its velocity is 4.5 and it is from the right, so it is positive, and m 2.8, it is from the left, so it is negative, equals minus 50 because it is from the east towards the left, so it's negative 50 into 1.8 plus, and it is right from to the right, so it is positive m 1.4. So 2 to 5 minus 2.8 m equals minus 90 plus 1.4 m. So adding it is 225 plus 90 equals 315, and 2.8 plus 1.4 m is 4.2. So m equals 75 gram. Next, state and explain whether the collision is elastic. So one way is to find out the total kinetic energy before collision should be equal to the total kinetic energy after collision. So, and another way is to consider that, let's say it is elastic one. So if it is an elastic one, so the relative speed of approach should be equal to the relative speed of the separation. So adding the speed, which is 4.5 plus 1.8, it is the relative speed of approach, which is 6.3 meter per second, and the relative speed of separation is 2.8 plus 1.4. So they are in the separation mode, so it is adding, which is 4.2. So as we could see, that 6.3 is not equal to the 4.2. So that means relative speed of approach is not equal to the relative speed of the separation, so the collision is not elastic. C. Use Newton's second and third laws to explain why the magnitude of the change in momentum of each ball is the same. So from the third law is force of x on y is equals to the force of y on x, and for the second law the force is the rate of change of momentum, so that rate of change of momentum of x due to y is equals to the force rate of change of y momentum of y due to x. So since the collision is the same, so change in momentum of x on y is equals to the change in momentum of y on x, and we can easily find out change in momentum, which is 50, and for the rebound velocity should be add, so 4.5 plus 1.8, 6.3, and for y is 75. We just found out, so 75 into 2.8 plus 1.4, which is 4.2. So 315 is equals to the 3.5. So left hand side equals to the right hand side. So that means the magnitude of change in momentum of each ball is the same. So this is the solution of this question.